everyone. Today we will discuss Physics IGCSE 2021 January Paper 1. First question. The passage describes the evolution of stars with a mass that is much greater than the mass of the Sun. Use words or phrases from the box to complete the passage. Each word or phrase may be used once, more than once, or not at all. The words that they have given is chemical, kinetic, protostar, contract, a main sequence, supernova, expand, neutron star, vibrate, gravitational, nuclear, and white dwarf. We look at the paragraph. Hydrogen atoms in a nebula move towards each other due to the force of gravity. As the atoms move towards each other, the kinetic energy store increases because they move towards each other, so that they start moving faster due to the gravity. So the answer will be kinetic. Store increases, which increases the temperature. So we know that the temperature and the kinetic energy is proportional to each other. If the temperature becomes high enough, nuclear fusion of hydrogen will start and the star enters the main sequence stage. Of its evolution. When hydrogen fusion stops in the core of the star will start to contract. We had the term contract. This increases the temperature in a layer surrounding the core. Hydrogen fusion restarts in the layer surrounding the core. This causes the star to expand, and its surface temperature decreases. The star is now a red supergiant. Eventually, nuclear fusion stops in the core of the star and the star explodes as a supernova, because we know this is a massive star. And also the core of the star collapses to form either a black hole or a neutron star. So the black hole is given, so it has to be neutron star. Next question. A speed camera is positioned at the side of the road. The camera measures the speed of the vehicle on the road to determine whether the vehicle is traveling too fast. The camera takes two photographs on the vehicle 0.25 seconds apart. The photographs are used to measure the distance traveled by the vehicle during the time. State the formula linking average speed, distance moved, and the time taken. So we can write average speed equals distance moved divided by time taken. Let's move to next question. In the time between the two photographs, the car travels a distance of 6.5 meters. Calculate the average speed of the car. So the distance is given. Time, we know that in between each photograph there will be 0.25 seconds. So that we will find out the average speed. Distance is 6.5. The time is 0.25. The answer is 26 meters per second. Moving to next question. The speed limit of the road is 80 kilometers per hour. Determine whether the car is exceeding the speed limit. Now we need to convert this 26 meters per second to kilometers per hour, or you can do the other way around. You can convert 80 kilometers per hour to meters per second, but I think it's easy. It's straightforward. If you try to convert this 26 meters per second into kilometers per second, then you can compare very easily. Otherwise, you'll have to do this other one conversion. Okay, we'll do the conversion for 26 meters per second to kilometers per hour. So first of all, this value has to be divided by 1000. Then you'll get kilometers per second, and this will be 0.0 to 6 kilometers per second. Now in order to convert this into hours, you can multiply by 3600 so that you would get the answer 93.6 kilometers per hour. Which means this goes faster than the. So we can write the vehicle travel too fast, or the vehicle exceed the limit of 80 kilometers per hour. Because answer is almost 94 kilometers per hour, which is bigger than 80 kilometers per hour. Next one, the velocity time graph shows how the velocity of a lorry changes with time. Explain how the graph shows that the lorry has a constant acceleration. We know in a velocity time graph, if the line is having a positive gradient or constant gradient, it's a constant acceleration. So we'll write down acceleration is the gradient of the graph. Next one, state the formula linking acceleration, change in velocity and time taken. We know acceleration equals change in velocity divided by time taken. Going to next. Calculate the acceleration of the lorry. Now in this case we need to use the gradient method. I'll note down the values over here. This is 24 and the other side is 60, and here it is 5. The time is spanning from 0 to 60. So I can write acceleration equals final velocity was 24 minus 5 divided by time is 6 minus 0. The answer will be 60 minus 0. Answer will be 0.32 meters per second square. So it's better to start writing A equals V minus U over T, or the gradient equation y2 minus y1 over x2 minus x1. The photograph shows a mains operated decorative lamp X. Third question. The photograph shows a mains operated decorative lamp X. Lamp X has 7 identical bulbs that are connected in series. Give a disadvantage of connecting the bulbs in series. We know in the series circuit, if any component is broken, even all others will stop working. So we'll note down about that. Second one, suggest an advantage of connecting the bulbs in series. We know that series circuits are simpler to connect, and less amount of wires, and also all the bulbs are connected by using, all the bulbs are controlled by using one switch. Next question. Each bulbs have working resistance of 390 ohms. Voltage across each bulb is 33 volts. State the formula. We know voltage equals current into resistance. Calculate the current in each bulb. So we will write current equals voltage over resistance. V is 33, resistance is 390. The answer is 0.0846, but we will write 0.085 amperes. Moving to next question. Calculate the energy transferred to lamp X when it is used for 2.5 hours. We can find out the energy by using E equals VIT. Now V is 33 per one bulb and the current is 0.085, the time is 2.5. We need to multiply by 3600 because the time should be written in seconds over here. So the answer will be calculate the energy transferred to lamp X. This energy is 25,245, and we know there are 7 bulbs, so that answer has to be 176,715. $25,245 joules for all 7 bulbs. Energy equals to 25,245 into 7. Answer is 176,715 joules. Next question. So that energy transferred is another decorative lamp Y uses 5 of the same 390 ohm bulbs connected in series. Both lamps are mains operated. Explain how the brightness of a single bulb in lamp Y compared to brightness of a single bulb in lamp X. In lamp Y there are only 5 bulbs, so that it's having less number of bulbs. So more voltage will be shot in lamp Y, so that the brightness of bulbs in lamp Y will be more. And more energy transferred to each bulb in lamp Y. and also resistance in the bulb Y, sorry, lamp Y is less, so that more current is passing through. That's the reason the brightness is greater. Okay, moving to next one. You can talk about the voltage as well. The voltage compared with the voltage shared between the bulbs in lamp Y. Yeah, I will note down that as well. Moving to next one. The photograph shows a hairdryer plugged into the mains power supply. The hairdryer contains a fuse. State which wire in the hairdryer should be in series with the fuse. We know that it has to be the live wire. And the next one, the fuse in an electrical safety feature used in mains operated domestic appliances. State two other electrical safety features that can be used in mains operators domestic appliances. We know that this can use, they're only asking about the safety features, not explanations. So earth wire can be used. Then we know the circuit breakers can be used. Other than these two, we can use double insulation. And also insulated wires or insulated cables can also some kind of a safety feature. Next question. The hairdryer has a current of 9.6 amperes. The main supply voltage is 230 volts. State the formula linking power, current and voltage. We know that the power is equals to current into voltage. Calculate the power of the hairdryer. So power equals current is 9.6 into 230. Answer will be 2200, almost 2200. And the unit will be watts. Moving to next one. The hairdryer contains a coil of wire which is used to heat air passing through the hairdryer. Explain why the coil of wire heats up when there's a current in it. We know that when the excessive current is passing through, or like when the current is increasing, the electrons, the coil has these electrons and also coil has this resistance, and when the electrons are passing through, electrons collide on the lattice structure and it transfers energy in the form of heat. So we will note down about that. coil has a resistance. When current flows, electrons transfer through the coil. These electrons collide with lattice ions in the coil and electrons lose energy as thermal energy. Moving to next one. Explain how a fuse protects a domestic appliance. We know that a fuse has a specific current rating. So if the current exceeds this value, the fuse will melt and it will break the circuit. And it will break the circuit, which prevent current passing to the appliance. Fifth question. A teacher uses radioactive source containing atoms of the isotope radium-226. Give a safety precaution that would reduce the teacher's exposure to radiation when working with the radioactive source. We know there are three ways that we can be safe with radiation. One is reducing the time exposure, second one is increasing the distance, third one is using shielding. So if you have written any appropriate answer related to those three, the answer would be correct. So we can say to increase the distance, the source can be handled by using tongs. And also we can store these sources in a lead box so that there will be shielding. And also we can simply say minimizing the time handling the source and maximizing the distance from the source while we use it. Like when the students are seated also, they have to stay a little bit away, but in this question they are talking about the teacher. And taking care of the direction of the emission of the source, and usually we don't point the source towards the people, even though we want to show it will be kept away. And we can use a lead apron or shielding in order to safeguard ourselves. So I'm going to write only one, handling the source with tongs. We do this one to increase the distance. You can say to increase the distance. Next question, radium-226 can be represented using this following symbol. How many neutrons are there in the nucleus of the atom? So we know in order to find out the number of neutrons, we can subtract atomic number by mass number. I'll write the equation for you to do it easier. Minus atomic number. So the values will be 226 minus 88. Answer will be 138. Answer here is B. Moving to next. The teacher investigates a type of radiation emitted from the radioactive source. Give the name of the piece of apparatus that detects ionizing radiation. So the most common thing that we have discussed is the Geiger-Müller tube, or you can use photographic films as well. Now, these photographic films are some specific type of films. Question C, part 2. The teacher finds that the radiation emitted from the radioactive source is not detected when the detector is more than 5 centimeters away from the source. State the type of radiation emitted by the radioactive source. We know that alpha is having a very small distance in the air, or it has less penetrating power as well, or mostly that's the shortest, alpha is the one which is having the shortest distance in the air. So we can write this as alpha. Move to next question. Number of radium-226 atoms in the source decreases over time with the half-life of 1600 years. State what is meant by the term half-life. This is a very common question in most of the exams. I have seen this. So first thing is, it is the time taken. For radioactive nuclei to decay into half. Or say half of the original activity. We can write this in like few different ways. Time taken to halve the radioactive nuclei. In different ways you can write, but the meaning has to be there. Time taken for radioactive nuclei to decay into half of the original activity. Going to next one. The radioactive source contains 2.66 into 10 to the power 21 atoms of radium-226. Approximately how many atoms of radium-226 will remain in the source after 800 years? Now this one, if you do the calculation, we can find out after one half-life, the amount of radium atoms will be 1.22 into 2.66 into 10 to the power 21 divided by 2. So that the answer will be 1.33 into 10 to the power 21. But we know the half-life for this atom is 1200 years. Radium 226 is taking 1200 years for to turn into this value 1.33 into 10 to the power 21. So the original value is 2.66. This is after one half-life. But this is after this much of time. So this is the original. But they say the time is like source after 800 years. 800 years is less than 1600. So the answer has to be C, which is in between these two values. Without doing any calculation, if you just roughly look at what is the answer for after one half-life, you can compare these values and find out the answer. Moving to next. When a rubber ball is dropped, it hits floor and bounces. Design an investigation to determine how the temperature of the rubber ball affects the maximum height the ball reaches after it bounces. In your answer, refer to how to change the temperature of the ball, the variables that need to be controlled, how to obtain high quality data. You may draw a label diagram to support your answer. Now, whenever there is this sentence, you may draw a label diagram, that means it's better to draw it. Like, even though that your explanation doesn't make much sense, the written explanation, if you have drawn something which looks like the experimental setup, the proper experimental setup, and also it has like represented some steps, so you might get the marks, even though that your explanation, the sentence is meaning something else. So better to draw when they say this thing. And I will highlight a few more things. Here they say how the temperature of the rubber ball affects the maximum height after bouncing. So the maximum height after bouncing will depend on the temperature. So what they say is how to change the temperature. The variables need to be controlled. That means the control variables. And also how do we take high quality data. That means how do we make it more accurate. So first thing you can do is, I will draw a small diagram. Now, when we are changing the temperature of this ball, a better method is to use a water bath, because when we use a water bath, equally all the points in that water container will have the same temperature. Rather than exposing the ball into a direct flame, the best method is using a water bath, or you can use a oven even, and also you can use a freezer to decrease the temperature. Yeah, so I will draw a diagram of this water bath. I will quickly draw a beaker and fill it with water. I'll insert this ball inside a tripod. And also you can have a Bunsen burner down here. My diagram is not neat enough. You can draw a better one by using the pencil. So this is the water bath. This is the ball. This is the Bunsen burner. Now another diagram you can draw, a ruler. Now when we bounce back, we need to measure it, right? So you can drop this ball. So the ball will be dropped and this will be the floor. And this will be the meter ruler. You can mark it in a way that they will, anyone who's looking at this will understand this is a ruler. This is the ball. And this is the meter ruler. I'm moving down to write down this explanation. You can see this is a 6-mark question. So we need to write the steps and clearly explain what are the instruments to use. First, I can mention about this water bath. Use a water bath to change the temperature. Of the ball. Then another very important thing is, I forgot to draw it here as well. We need to use a thermometer in this. Because in this experiment at the end we need to draw a data set or like a table. There are the temperature and the bounced height will be written in the x and y axis, or like in those two columns it has to be temperature and the height. So in order to measure the temperature we need to have a thermometer. Second one, we need to mention about the control variables. In the control variables, we need to keep constant how much is the height that we are dropping this ball, and also the bouncing surface we need to keep constant, and also each time we have to let it just, we need to just release it, not force it, I mean not throw downwards, we have to release it with rest. So the things to keep control, I will say control variables. Has to be kept same. And also the ball should be released from rest in each time. Then we need to explain how do we acquire high quality data. That means, first thing, the easiest thing is we repeat the experiment. That's what we usually do. Repeat the experiment. I want you to connect these answers and write. I'm just pointing out what are the correct points to write, but I want you to write it as a paragraph, or like even though it is in the point form, connect each one properly. Other than this one, like we can repeat and find out the average. Other than that, what we can do is we can plot it into a graph, and also we can ignore the anomalous values, and also these recordings we can do from the eye level, because if you measure it from a different place, there can be parallax error. I will say to reduce error, measure at the eye level. Seventh question. Very strong magnets can be made using the element neodymium. Diagram 1 shows parts of two neodymium magnets X and Y when they are held close together. So in this one they have given south pole marked. Let's look at the question. A uniform magnetic field is produced in the space between the magnets. Diagram 1 shows the south pole of magnet X. Complete diagram 1 by drawing the uniform magnetic field and labeling the pole of magnet Y. So we know in order to create a uniform magnetic field, here it has to be north pole. And also to draw these field lines, it will be a little bit hard for me since I'm drawing on the screen. I will try to draw as much as correctly as possible. So the line has to be parallel to each other, and also they have to be equally spaced in between, and it has to go from north to south, equally spaced, parallel to each other. Okay, my drawing might have small issues since I was drawing with freehand, so make sure that you use a ruler, and if you can keep a ruler and see whether there are equally spacing in between also, that would be preferred. And here that there are small spaces in between the magnet and the line, but don't leave spaces like that as well. You have to complete it from the north pole to the south pole fully. Moving to next question. Diagram 2 shows another neodymium magnet being used to lift an iron ball from a table. The iron ball is shown at the instant it leaves the surface of the table. So if it is moving up, if it is lifted, that means the magnetic force is higher than the weight. So they are saying explain why the iron ball experiences an upward magnetic force. Because iron is a magnetic material, so that it becomes magnetized, or like it induces the magnetism, so the iron ball is attracted to the magnet. Let's write down that. So iron ball becomes magnetized, so it is attracted to the magnet. Look at the next question. The iron ball experiences an upward resultant force at the instant shown in diagram 2. Draw a labeled arrow on diagram 2 to show the weight of the iron ball. So we know that this is going to be lifted. So if it is lifted, that means the weight is smaller than the magnetic force. So we will draw an arrow which is aligning this magnetic force line, but this weight arrow has to be smaller than the magnetic field arrow. Make sure to label it as well. Moving to next question. State the formula linking weight, mass and gravitational field strength. We know weight is equals to mass into gravitational field strength. Next one, at the instant shown in diagram 2, the resultant force acting on the iron ball is 124 millinewtons. So this is something tricky now, millinewtons, and magnetic force is 165 millinewtons. Calculate the mass of the ball. We can write down W equals mg. First of all, we need to find out the weight. So weight equals 165, which is the magnetic force, minus 124, which is the resultant force. But this is in millinewtons, so I will say, find out the answer, that will be 41 millinewtons. Then I'm going to use W equals mg. In W equals mg, I need to find out mass, so that m equals W over g. W is 41 into 10 to the power minus 3, because milli stand for 10 to the power minus 3. Divide by g is 10. So my answer will be 0.0041 kilograms. 0.0041 kilograms. Next question. Explain why the resultant force acting on the iron ball increases as the iron ball moves towards the magnet. We know when it moves towards the magnet, the magnetic force increases, or like simply the magnetic field strength increases. So I would start saying that when the iron ball taken closer, the magnetic field increases. Then magnetic force increases. But weight of the ball stays the same. Due to that, resultant force increases when iron ball move towards the magnet. Eighth question. A student uses a computer simulation to investigate the motion of particles in a gas. He records the pressure of the gas and the mean speed of the particles in the gas at different temperatures. The graph shows his results. You can see that the temperature measured in degrees Celsius and the pressure. After that, temperature in degrees Celsius along with the mean speed of particles in meters per second. Question A. Give a reason why the student does not start the y-axis scale from 0 on either of his graph. You can see that over here, both of those are not starting with 0, like even though that the temperature is 0 degrees Celsius. So the reason for this one is there will be always some pressure, because it's not absolute 0. This is 0 degrees Celsius. The absolute 0 from degrees Celsius is minus 273 degrees. So we'll note down those points. Describe the relationship shown by the graphs. So the first graph about the temperature and the pressure is directly proportional, but we can't say directly proportional for degree Celsius. So we can say as the temperature increases, the pressure also increases. But we can say this relationship is a linear relationship. Between temperature and pressure. In the second graph, we can see it's a little bit of a curve, so that graph is not a linear relationship. So we can say it's non-linear. This is the graph between temperature versus mean speed non-linear relationship. And also in that the gradient is eventually or gradually decreasing. Gradient decreases gradually. Moving to next question. Explain why the value of temperature chosen in the simulation should not decrease below minus 273 degrees Celsius. So we discussed a little bit about this absolute zero already. So at minus 273 degrees Celsius, we know that there is absolute temperature. So we write down this temperature is known as absolute temperature, absolute zero. It's very important. And also we know that the pressure or the kinetic energy of the particles will become zero at this temperature. And kinetic energy and yeah. Next question. The student then calculates the kinetic energy of a single gas particle at each temperature. Using the curve of best fit on graph 2, determine the mean speed of a gas particle when the gas temperature is 100 degrees Celsius. We will look at the graph and mark it on that. See, 100 is over here. So if you draw a dotted line for 100, and if you draw the this line to this, that's meeting over here. Okay, so it is 520. So you have to show it on the graph itself, and after that only you can take the value. So that the answer is 520 meters per second. The next question, the mass of the single gas particle is given over here. Calculate the average kinetic energy of a gas particle when the temperature of the gas is 100 degrees Celsius. To find out the average kinetic energy, we can find out the kinetic energy equation, which is half into m into v square. So mass is given over here now, 5.3 into 10 to the power minus 26 into the speed is 520 square. So the answer will be 7.2 into 10 to the power minus 21. So this can be 7.16 into 10 to the power minus 21 also, but I have rounded and written the answer. Next question. Calculate the temperature of the gas in Kelvin when its temperature is 100 degrees Celsius. You know that the Kelvin can be calculated by adding 273. So 100 plus 273, the answer is 373 Kelvin. Next question. On the axis, sketch a graph of the average kinetic energy of the gas particles against temperature in Kelvin. When temperature is given in Kelvin, we know that the average kinetic energy of the particles are directly proportional to each other. So we can draw a line which is going through the origin, straight line like that. So adjust it a little bit so that it goes through the origin. Like that. It can't go below the origin as well. So I will start with origin and continue. Moving to next question. A student does an investigation to determine the refractive index of a block made from flint glass. She directs a ray of red light at the block as shown in diagram 1. Some of the light is reflected from the surface of the block at point A. On the diagram, draw this reflected ray on the reflected ray of light. We'll use an arrow to point this direction. We know when the reflection occurs, there will be the light coming towards the same direction. So in order to draw that, we need to have a normal line at the point where the light is incident on, and I will use this arrow and try to draw the reflected ray. So when you draw that, I want you to be very careful with the angles that you are using. So over here, this is the angle of incident, and this value, if you're getting 60, this side also it has to be 60. I'll move to next question. Use a protractor to determine the angle of incidence and angle of refraction of the red light at point A on diagram 1. If you use the protractor and measure, here I value will be 60 degrees. And in this side, the angle when you measure, you have to use the normal, like the ray, the light ray, and the normal, like that is the angle in between. So R is over here, the value is 31 degrees. It can be a little bit slight of a different when you measure maybe. So make sure that you keep the protractor properly and take the reading. Moving to next one, state the formula linking refractive index, angle of incidence and angle of refraction. So as I explain usually, I would recommend you to use the notation form n equals sine I over sine R rather than using the word equation. This would be preferred. Calculate the refractive index of a glass for red light. Now we can use the the same equation and substitute n equals sine 60. We have calculated the values already. Divide by sine 31. N answer is 1.68. It's almost 1.68. Next question. Describe how the student could improve her investigation to obtain more reliable values for the refractive index. First thing is, like the most common thing, we can do the experiment. We can repeat the experiment for the specific angle, and also the next thing is you can vary this angle. I'll note down those two. Change the incident angle and get a set of data. And next one is we can find out mean value for the angle of I and mean refractive index for that then. Or what you can do is you can plot a graph between sin I versus sin R for the set of data. I would write that. Plot a graph of sin I against sin R. Sin I against sin R. And also, if you draw the graph like this, the gradient will represent the refractive index. So we can say find the refractive index from gradient of the graph. Part B, the student replaces a red light with blue light. Diagram 2 shows a ray of blue light directed at point A and the same angle of incidence as the previous ray of red light. The dashed line on diagram 2 shows the previous path of the ray of red light. Blue has a higher frequency, so it will refract more. I will draw the normal line over here to understand or to predict what happens. That's a normal line, and I will draw another line like that. It has to start from here. It will bend towards the normal a little bit more than the red light. Then I will draw the normal as well in this point. And once again it will go back to the original point, original angle which it was moving off where the light ray was going at the beginning. So angle of incidence and the angle of this immersion will be the same, but the angle of refraction will be different to each other because of the difference in the frequency. And there has to be this arrow pointed towards this direction. Moving to next question. Complete the diagram 2 by drawing the path of blue light. 10th question. The photograph shows a large hurdle on an athletics track. The bar of the hurdle is made of wood and painted with black and white. The temperature of the hurdle increases when the sun shines on it. Explain which part of the bar reaches the highest temperature. We know that the radiation, like the infrared radiation which is coming from the sun, the absorption changes depending on the colors. So black is a good absorber so that it can increase the heat energy more simply because of the color. So we'll write down black is a good absorber of radiation, so that black parts reach the highest temperature. On to next one. The air near the bar receives energy by heating. Explain how the convection current is formed in the air near the bar. This happens in stepwise, you know already. We'll write down the steps. First of all, the temperature closer to the bar will increase. The air particles heat energy and increase temperature. So that we know air particles move further apart. When they have higher energy, they have higher kinetic energy as well, so that they will move further away from each other. Further apart. Then we know that the volume increases. Due to that, density of the air decreases. Due to this reason, when the density of the air decreases, the warm air start rising. And the cool air will replace the places where the warm particles were. And this process repeat. Convection current occurs. Formed. Next question. A student uses a bottle and a stopper to find the density of an unknown liquid. The stopper fits tightly into the bottle and has a small diameter hole through it. This is the student's method. Use a balance to find the mass of the bottle and the stopper. Completely fill the bottle with water. Insert the stopper and dry the outside of the bottle. Use the balance to find the mass of the full bottle and stopper. These are the student's results: mass of the empty bottle and the stopper, mass of the full bottle and the stopper. Use the student's results to determine the volume of the water in the bottle. Give your answer to the three significant figures. We will do the calculation by using the density equation, which is density equals mass or volume. So since you need to find out the volume, we have to rearrange the equation. Density equals mass or volume. Volume equals mass divided by density. Now we already know that the mass is given, but I'm going to convert this. We'll see. Before converting, no need to convert because the density is given in grams per cubic centimeter. So mass is 100. They have given two of these values because full bottle and the empty bottle. So 112.9 minus 63.4 will be the mass of the liquid divided by the density, which is 0.9. 998. So that the answer, when you do the calculation, you're getting 49.599. Since they ask us to give the answer in 3 significant figures, it has to be 49.6 cubic centimeters. Next question. The student empties the bottle and then dries it. He refills the bottle with the unknown liquid. He measures the mass of the full bottle and stopper as 143.8 grams. Calculate the density of the unknown liquid. Now we already know the volume of this container now. So you can find out the mass of the liquid. Equals 143.8 minus 63.4. The answer will be 80.4 grams. Now you know the volume already, which is 49.6. Density equals 80.4 divided by the volume is 49.6. So that you get the answer as 1.62 grams per cubic centimeter. 1.62. Next question. Another student uses a measuring cylinder to find the volume of the unknown liquid. Discuss the advantages and disadvantages of using each method to find the volume of the unknown liquid. There can be advantages and disadvantages of both of these, yes. So that first we will discuss about using a measuring cylinder. If you use a measuring cylinder, you can read the volume to nearest cubic centimeter, and also it's easy to use the measuring cylinder and it does not need to be dried, like you can directly insert it, and also when you pour it, it's not going to splash everywhere. It has a nice shape at the tip so that we can nicely flow the liquid out. So we'll note down about the measuring cylinder. But the problem is measuring cylinder value can be incorrect with the parallax error. We can measure it a little bit wrong if you keep the measuring cylinder in a different place than the eye level. Next one, if you need to talk about the bottle. Now when you are using bottle, it gives the volume to nearest 1 decimal place that we can calculate. That means that allows density to be more precisely determined, but it's hard to use this bottle. It's not easy to use a bottle. You can say bottle is hard to handle. You can say difficult to handle. But bottle allows density to be more precisely determined. More precisely determined. That's it then. Thank you. You can like the video if you enjoyed this or if you learned something, and please make sure to subscribe to the channel as well.